Hi. Okay, in this example, we're going to use a couple of advanced features of X-ray. We're going to do a couple of things based on time, and we're going to show two different kinds of workloads operating on three different hosts. So on the first host, we actually start running this OLTP database simulation. The idea here is that we're trying to maintain 4,000 IOPS, so the workload is fixed rate. And as long as we can maintain about an 8 millisecond response time, then we can achieve those IOPS given the amount of concurrency that we have. So we initially start this workload and just the OLTP workload is running. You'll see the DSS IOPS on the lower half of that screen are 0 because we only have that one workload running and there's no competition. If you look at the response time underneath that, the latency, that's around about somewhere between 1 and half a millisecond. So we're well within the 8 millisecond response time at this point. So what will happen is about 30 minutes after this test, I've sped up the replay here. 30 minutes after the test, we will actually start running competing workloads on the other two nodes. And what's interesting about this, and what's nice, one of the nice things that X-ray does for us, is that it allows us to specify a completely different kind of workload on the other nodes. In this example, I'm running what I'm calling a reporting workload on the other two nodes. That's the DSS portion here. And what that is a very sort of highly sequential read workload. So it's simulating an analytical or reporting database. And the idea here is to understand what happens to the OLTP response time and the IOPS once those other two workloads begin. Now, we should expect that some kind of interference happens because the cluster is going from an otherwise idle state, so all the other nodes that are not running the OLTP workload currently are idle. And once we start running the other workloads, then of course the cluster will become non-idle. So we should expect to see some kind of behavior. We'll see the behavior change on the OLTP workload, but the question is how much will we see, and will it impact the number of IOPS that database is doing? Okay, so here we are. We just started to run the OLTP, so the DSS workload on nodes 2 and 3. And immediately, if you look at the bottom two rows there, you'll see the DSS IOPS. The DSS IOPS are relatively low. They're about 1,400 IOPS. But the key thing here is that they're 1 megabyte I/O, so they're actually moving quite a bit of data from the disks in this case. So if you look at the OLTP IOPS at the very top there, we are actually still maintaining those 4,000 IOPS, which is the goal. If you look immediately underneath that, you will see that the response time, the I/O latency, has in fact increased, which we expect because, as I said, the cluster has gone from an idle state to a non-idle state. But again, the key thing is that the OLTP IOPS are still able to generate or maintain the 4,000 rate, which I initially specified. So in this case, think of this as a database that is mostly doing CPU work on the database server itself, and it's generating 4,000 IOPS. Even if the response time is much quicker, as it was in the first case, it doesn't mean that the IOPS go any quicker. We're simulating a workload that just generates 4,000 IOPS. So we'll see here the response time has increased, but it's still able to make that IOP rate. And these two DSS VMs here they're on other nodes, and they're working away. And there's very little impact to the OLTP workload, even though it's very latency sensitive. So in this example, we've shown how you can create dissimilar workloads. One is DSS, one is OLTP. And we've also shown how in X-ray you can begin things on different times. So we started with no interference, and then we started these interfering workloads about 30 minutes into the run. And of course, we're using the X-ray graphing capability to show you what happens. So there we go. And after this workload is completed, I can of course generate the report that I showed earlier. And also, if I was doing this across different kind of hyperconverged platforms, I could use the comparison feature to look at how the different runs differ.